Okay, so we're going to talk about something completely different, which is the role of you and me and all of us to try and also kick this system which is stuck. And let me introduce you, therefore, to a social scientist who's going to bring a different perspective to our discussion. Charlie Wilson is senior researcher from the Tyndall Climate Research Center, and he's worked on a huge project which has some glimmerings of hope if we all reform our ways. Charlie.
Thank you. So much of the discussion this morning was on big tech, big infrastructure, big supply-side solutions happening kind of well away from us, offshore, underground, and distant from our everyday experiences. And I want to bring this conversation back closer to the familiar stuff of our everyday lives and remind us that the reason we have an energy system is to provide us with useful services. And so thinking about energy services is a critical part of this energy transition conversation. Now, I want to start by bringing you back to the 1970s, where this image towards the top left shows the computing industry, in which the customers of computers, the consumers of computers, were demanding mainframes with ever greater power, speed, storage, and so forth. And then along comes the microcomputer. It competes really poorly on these mainstream attributes, but it offers something very distinctive and new. And we know what the history of that industry was, because the microcomputer is now pervasive in our daily lives. And Clayton Christensen, a Harvard Business School professor, wrote a book called The Innovator's Dilemma, in which he characterized how these disruptive innovations, which offer novel value propositions to consumers, can rapidly change markets. Now, it's all very well thinking about computing, but what about disruptive innovations which could also potentially help reduce emissions rapidly by offering us new attributes? So we've been looking at many examples of these. Here are some relating to the provision of mobility, alternatives to the car. You may be familiar with some and less familiar with others. The one towards the top right, MaaS, stands for Mobility as a Service. So the idea that we can transition to a subscription-based form of urban mobility involving different modes. Here are a range of examples relating to our daily lives at home. So on the left, you see some peer-to-peer business models, P2P, so the exchange of goods or space or other assets. And then towards the right, you see some more kind of tech options to do with smart home technologies, Internet of Things, and so on. And then down here, finally, we see some examples relating to how the energy supply interacts with us in our homes. So on the left, PV with storage and even into peer-to-peer electricity trading. And on the right, a variety of business models and services which are starting to reconfigure how we, traditionally as passive consumers of energy, can move towards playing a more active and interactive role in the energy supply. So underlying this sort of set of potentially disruptive innovations are two major trends. One is the pervasive digitalization of daily life. And this is opening up this interesting kind of consumption shift from owning goods to consuming or using services. And we see this really clearly in the way we now consume media. We no longer buy, or it's relatively uncommon now to go out and buy CDs and DVDs. Rather, we stream media and we access the service it provides. Now, similarly, the kind of sharing economy business models we're starting to see in transport, in homes, and even in the energy supply are similarly offering opportunities to shift from owning goods to using services. Here are three examples, and others in the sort of set of potentially disruptive innovations that I showed earlier also have this characteristic of usership rather than ownership. Now, as a thought experiment, to sort of push this to the extreme, imagine that the set of single-purpose devices and appliances on the right that we might have in our homes, anything from videos and radio alarm clocks and set-top boxes and cameras and so forth, are replaced by a single device, the smartphone, which allows us to access the service that those single-purpose devices currently provide. What percentage electricity would we need in order to power the smartphone on the left as opposed to all the devices on the right? It's a thought experiment. But if you look at the power consumption when in use, you've got about 100-fold energy saving from the smartphone on the left compared to the devices on the right. And even if both sets are in standby mode, you've got about a 33-fold power saving. So clearly this is a simple calculation, but it shows the potential for these innovations to help reduce energy. So the second major trend alongside digitalization is decentralization. There's this proliferation going on of small-scale, granular, user-sized, relatively low-cost energy technologies on both the demand and the supply side. And this is having an effect that consumption is shifting from a sort of atomized, independent, end-of-the-pipes and wires kind of mode to more of a networked mode of consumption. And this network consumption can either be through networks of people, as in, for example, sharing economy business models, or more commonly through networks of information, as in all of the technologies which rely on big data and data analytics and connection to the internet in order to deliver us useful services. So again, those were three examples. Here are some more from the set of innovations I showed you at the beginning. And so this is a key element in what we're interested in terms of potentially disruptive innovations. Now, it's not enough for them just to be out there and starting to appear in our lives. We need to know they can also reduce emissions if adopted at scale. And the evidence base is still relatively thin, but it's growing, both from simulation and modeling studies and also from empirical studies and field trials. And with a large group of colleagues led by Arnulf Grubler at EASA, an institute outside Vienna in Austria, we tried to contribute an additional piece of evidence to this evidence base by looking out into the future to 2050, and we developed a scenario that we call LED, or low energy demand. Now, this scenario is characterized by a narrative, a story of change represented in this figure. So in the outer circle are these 5 big picture drivers of change from 2020 to 2050. Rising quality of life, particularly in the global south, urbanization, a diversification of end user roles from passive consumer to more active participant in energy systems, rapid and continued innovation in information and communication technologies, and then all of these new forms of energy service which I've talked about. So big picture drivers of change, which then map onto 5 more specific ways in which energy services can transform. And all of these I've talked about: decentralization, granularity or small-scale technologies, usership, and digitalization of daily life. We took this scenario narrative and we mapped it down onto the 4 main energy and resource-intensive services which we enjoy as part of our daily lives: thermal comfort, consumer goods, ownership and use of consumer goods, mobility, and food. And for each of those, we thought about the amount of energy services we would need to consume, particularly in the global south, to make sure living standards continue to rise. But we also looked at the reductions in energy needed to provide those energy services. So we call this energy intensity. Now, for each of those energy services, if you take the amount of energy service and the intensity of the energy service and combine those 2 numbers, that gives you energy demand. So we looked at this both downstream or for end users and the implications upstream in the supply chain for commercial buildings, construction, industry, and so on. And by combining all these estimations to 2050, we generated an estimate of global energy demand, which is 40% lower in 2050 than it is today. And this is shown in this ruler. So the green line, where it says LED, is around 250 exajoules of global energy demand, and that's about 40% lower than where we are today, which is the red line. Now, you'll see some of the other horizontal lines. You won't make out the words, but they're essentially other scenarios exploring this mitigation space. And so you can see that our low energy demand scenario is something of an outlier. We took those energy demand numbers and we fed them through an integrated assessment modeling framework, which basically allowed us to explore the consequences for the energy supply, for the land use system, and also the climate system and air pollution. And the results were very stark and very dramatic. So what this graph shows is the transition in energy resources going into the global energy system. The part on the left is the historical, from green, that's biomass, to gray and red, that's coal and oil as part of the Industrial Revolution, and then into the 20th century with the rise of natural gas, that's the light blue. The bit we're interested in is the next bit, the shaded bit from 2020 to 2050, which shows the rapid phase-out of coal and oil and the rapid growth of renewables, particularly wind and solar. But, and this is a critical point, because we've downsized the global energy system by 40%, the kind of growth rates you need in wind and solar to reach about a 60% market share by 2050 are 5 to 10% per year. So well within the bounds of possibility. And crucially, despite some of the things we heard this morning, our scenario requires no CCS, no fossil CCS, and no bioenergy and CCS. Now that's the future picture, and I just want to say one thing quickly about the historical picture. These 18 graphs show 18 different countries whose CO2 emissions from fossil fuels have declined on a sustained basis over the last 18 years, over the last decade. 18 countries who've peaked and declined their CO2 emissions. And one of the factors that explains across the board in these 18 countries how they've managed to do this is that energy demand has fallen. And so I really want to emphasize how demand and services is a critical element of the low-carbon transition and the energy transition. Now, just to leave you with this slide, this will not happen by magic. This is not manna from heaven. This requires a concerted program of action involving consumers and citizens and cities and innovators and service providers, as well as policymakers and energy supply companies. And we've identified 6 strategies which are central to our scenario narrative: electrification of energy end use, multifunctionality, usership or accessing services, increasing the utilization rates of energy-intensive and material-intensive goods, standards for pushing devices and homes and so forth up to the energy efficiency frontier, and finally, user-oriented innovation to deliver us appealing energy services which can also help reduce energy and emissions. Thank you very much for listening.
Wow, Charlie. Well, that was quite a canter through a very big program, a very big model with huge assumptions there. Is it too good to be true? I mean, I was pinching myself thinking, wow, 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 but we need to test him, yes? So hold your thoughts, please, and give him a hard time later, or a very nice time if you just want to make friends.